Hey guys, it's Jessica here, and today I'm going to go through with you more factoring of trinomials, specifically factoring by grouping, a review of that because we're going to use it in our larger idea today, the AC method. Okay, so you guys have been working with factoring, and we're just going to add some more tools to help you get these polynomials factored, okay? If I speak too fast, remember that you can pause this. Also remember that you should have a note sheet printed out, that you do have something to go off of that looks just like a lot of what we have on this video. And then also something to think about is that some of the problems on your worksheet I'm going to let you complete on your own. You will need to have those completed for your notebook check, but you can work on those and then check them with a buddy, check them in your lab group or with an instructor or a tutor, and make sure that you're understanding those so that you can do really well with them on your quizzes and on your test. Okay, so let's go ahead and get started. Just real briefly, we're going to go over our factoring by grouping review. Okay, 4 terms. Whenever you have 4 terms in a polynomial, that means that we are going to factor by grouping. That's what tells my mind, hey, I need to factor by grouping. Okay, so let's go ahead and let's get started with this one here. We're going to start by grouping our common terms. Okay, and so I'm just grouping those, the first 2 together and the last 2. And let's look at that first one. What can I take out of there? Well, I can take out a 3 in terms of my numbers, and also when I'm looking at x cubed and x squared, the greatest common factor of that one, I can take out an x squared. Okay, so then what is left? What's left would be 4x, that would give me the 12x cubed, and also minus 3x. Not 3x, just 3. Okay, because if I take 3x squared times negative 3, then yes, that's going to give me the negative 9x squared. Okay, so I want you to notice real quick, because this is a good example to start with. If I look at my first set of parentheses, I can see that what I'm going to factor next is matching it. And that's what we want in the long run, is we want our parentheses to be matching. Those are the common term. That's what comes out as the greatest common factor of the whole polynomial, but you probably can't figure that out just by looking at it, so that's why we use this method. Okay, so how do we keep that the same? We're just going to take out a positive 1. Okay, that leaves me with everything's the same. Divide anything by 1, it's just going to be whatever we started with. And so if you look at your steps, we're going to join what's on the outside. That's going to be one of our factors, and what's on the inside, it should be identical. That is our second factor. So we have 3x squared plus 1 as our first factor, and 4x minus 3 as our second. Okay, you can write those in any order. Okay, so problem B on your sheet, I want you guys to take a look at that. You can pause it and do it now and make sure that you're able to get that okay, or you can go ahead and come back and do those at the end. Okay, so let's look at our factoring with the AC method. That's going to be what we're doing next. So we have a lot of different ways that we factor, and that's probably the hardest thing about factoring, is deciding which one to do. Well, I'm going to tell you for the AC method, we want to look at when do we do this. We do it whenever our A term, which is what's out in front of our squared term, does not equal 1, okay? So first we have to have that in standard form. That is ax squared plus bx plus c, okay? So we're not going to have anything in front of x squared if a is 1. Okay, we don't typically write that 1 out in front of a variable. But if this a out in front is anything else, say 2, like we have down here in example A, or 3, 5, anything, then we need to go to this AC method and solve from there. The first thing we always want to check for is a GCF. Sometimes it'll make it easier on us to factor and make it so that we can do this more efficiently. Okay, so let's look. 2x squared plus 10x plus 12, I can take out a 2, and that leaves me with x squared plus 5x and plus 6. Okay, And so here we can see why this is helpful that we take out that GCF, because now we have a factoring of a trinomial, a quadratic, that is just like what you guys have been working on in your previous homework exercises. So for this one, I wanted to start with it because you can see when you take out the GCF, we can actually proceed as we normally would with factoring one of these. So I know I'm going to have an x out in the front. If I look at my signs of the middle and the last term, they're both positive, so that means both my factors are going to be positive. I don't have to figure out what needs to be negative. And what adds together to give me 6 but what multiplies to give me 6 but adds together to give me 5? Okay, if you need to write down the factors of 6, we can do that. I'm thinking that a positive 2 and a positive 3 is going to work. 2 times 3 is 6. 2 plus 3 is 5, so that's going to give us our middle and outside terms adding up to 5x, and we're done. So it helped to do our GCF. Okay, let's go on to our next one. Alright, this one, once again, we always want to check first for the GCF. However, this one has that 3 as one of its coefficients, so that means 3 is prime, so 3 would have to go into 8 or 4, which it doesn't. So that means we're going to go to our AC method. Something I'm going to show you guys here. It's kind of a way that's nice. Sometimes students can see it easier if we organize it, give us a visual. So we're looking for, if you refer back to your steps, you can always use those, we're looking for something that is going to give us the product of A times C. So whatever A times C is, in this case it is 3 times 4, okay? So that is 12, and then let's write our B term down here, keeping our sign, negative 8. So what those steps say is we need 2 factors of 12 that multiply to give us 12. That's what factors are, right? And they add to give us B, okay? Our B term. So let's think about that. And as I mentioned in the previous example, if you need to write this out, that's okay. Sometimes they jump out at you and sometimes they don't. So we have 1 times 12, 2 times 6, 3 times 4, we would have 4 times 3, but that's the same as the one we just did. So which one of those is going to give us 8 whenever we add them together? And not just 8, but negative 8 actually. So if we're looking at 2 and 6, yeah, they multiply to give us a positive 12, but we actually need to make both of those negative in order to get that sum, adding them together, to be negative 8, okay? So here we would normally fill in this negative 2 and negative 6, which we're going to do, and normally you would say, okay, I've found my factors. This is going to be x minus 2 and x minus 6. However, because we have that number out in front, can we stop here? Let's think about this. We can't, because if we were to FOIL this back out, which we can always check, okay, so what we're doing when we're factoring here is we're seeing what did we have, what factors did we have before we multiplied and distributed out to get what we're starting with. So it's kind of like working backwards. So if we did the first terms here and just left it without using our AC method, it would be x squared. And x squared is not equal to 3x squared. So we must do the AC method. Okay? So we have to do that. Alright, we cannot use this as our final answer. Okay? So let's do that up here. So if you look back at your steps, these factors that we found, those represent our middle term. Okay? So we're looking at, it says I'm going to keep that A term. I'm keeping the 3x squared. I'm going to write in negative 2x, that represents part of my negative 8x, and then minus 6x. And this is just from what we found initially, keep my C term of a positive 4. Okay? Alright, hey, I have 4 terms and I can factor by grouping. So that's the whole reason that we have this method, is so that we can do it more easily. So if I do this, I can take out an x from the first one, it looks like, and what does that leave me with? It leaves me with 3x and minus 2. And what comes out of that second one? That 6 has a negative in front of it, and I need a positive to match my first set of parentheses. So I'm going to go ahead and take out a negative, and what's our common term? It is 2, okay? So then negative 2 times what gives me negative 6? Well, there we go. It's a 3x, and so that's matching our first set of parentheses, and negative 2 times what is a positive 4? Negative 2. Okay, so like our method says, we're joining what's on the outside. What's on the inside is our common factor from the original polynomial. So our factors are x minus 2 and 3x minus 2. Okay. One thing I do want to add just real quickly before we go on, whenever we're up inserting our negative 2x and the negative 6x for our middle term, you can insert those in either order. It's going to look a little bit different, but it's going to give you the same answer. Same down here, we could have written 3x minus 2 first, and that's okay. So just little things that sometimes are frequent questions, and if you don't believe me on the order of inserting your negative 2x and negative 6x, I challenge you to check it. In fact, that might be nice just for some extra practice. Okay? All right, let's go on to the next one. Okay, so you'll see that we're going on to example 2. Example 1, I want you guys to try on your own once again and then get that checked. Make sure that you know how to do that so that you can do it for your quiz and your test, and you also will be checked on your notebook on that one. Let's look at number 2. What's our first step? Always to check for a GCF, okay? You guys are going to be dreaming of checking for GCFs because that's what we're doing on all of these, okay, in any factoring that you ever do. So what is my GCF on this one? It is 8. So I'm going to take out the 8, and that leaves me, whoops, that's going to leave me with, well, come on here. Okay, sorry about that, having some technical difficulties. That's going to leave me with x squared. Okay, and plus 4x and minus 6, it looks like. Okay. Oh, somebody catch me. Is it minus 6? No. 8 times what is negative 24? 8 times negative 3. Alright, so easy to do if we're going quickly. Okay, so let's look at this one. Whenever we go to C, now I don't have to do the AC method for what's left inside here because I don't have a coefficient that is not equal to 1. I have a 1 out in front. So how would I factor this one? I would keep my 8, okay, and then I would have these 2 factors, okay, and then what do I need to think about? I need to think about, okay, this first part's going to be x, okay, because that's going to give me my x squared. I have a negative for my c term, so that means that I need one term to be positive and one term to be negative. That's the only way we can multiply to get a negative if we're multiplying 2 numbers. So let's think about factors of 3 here, okay? What are my factors of 3? I have 1 and 3, and that's it, right? Because it's prime. So if I'm doing a product to get a negative, that means I have a couple of options. I could either have negative 1 and positive 3, or I could have positive 1 and negative 3. Okay, so do either one of those add up to be 4x, or our middle term of 4, our b term? So negative 1 and positive 3, that's going to be 2. However, 1 and negative 3 is going to be negative 2, and neither one of those add up to be our b term, which is what we're looking for, 4. So that means that we are going to keep this answer here. What's inside your parentheses does not factor any further. So what's inside the parentheses is prime. However, our answer for this one is not prime because we did factor something. We factored out that GCF of 8, okay? So that's a common mistake. You're not writing prime for this one. You're writing the factored out version. We did factor out that greatest common factor. Okay, once again, number 3 is going to be on your own. You guys are going to practice that one. And I will give you a hint on number 3, so maybe jot this down on your paper right now. Make sure you put that in standard form so that helps you out there, okay? And now let's look at number 4. So if I look at number 4 and I try to do that AC method, okay, I'm taking A times C for the top, and so that's going to be a positive 6. And on bottom, my B term, there's nothing written in front of that except for a negative, but that means it's negative 1. We know that. So let's look at our factors of 6. Okay, and we have 1 and 6, and 2 and 3. And you guys might be thinking, hey, 2 and 3 looks like it might be a winner for some combination to get negative 1. However, we have to be careful with our signs on this one, right? Because if I have a positive 6 that it's trying to multiply to be, then that means either both of them have to be negative, which does not give me a negative 1, or both of them have to be positive, a positive 2 and a positive 3, okay? So I'm not getting factors that are going to work for that. So this one is prime. We tried all of our factors and they're not giving us a solution. So this might be one that has a rational answer. It might have a complex answer. You guys will learn about that later on in your math classes and in this class, and different ways to handle these. But for right now, in terms of factoring, we're going to say that this one is prime. We don't have any integers that satisfy that, okay? So let's go on to our next one. Numbers 5 and numbers 6 are going to be on your own, as well as number 7. So like I said, make sure you try those. Make sure you, if you have trouble, make sure you ask someone, okay? Any of us would be happy to help. And let's go ahead and look at number 8, okay? So number 8, we have x cubed. Let me write this down for you real quick. X cubed plus 2x squared and minus 35x. This one you might notice looks a little bit different because we have just been factoring our quadratics. That means it's degree 2, which means that it has an x squared. Okay, so all that good math lingo. And so let's look at this one. This is our last one today. So first of all, I'm going to say it again. What is the first thing we always do? We look for a greatest common factor, okay? On this one, we have a coefficient of 1 on the first term, and then 2 and negative 35. So we don't have a number that comes out. However, let's look at x cubed, x squared, and x. What is our greatest common factor of that one? It is just x, okay? If that confuses you, think of it this way. You have 3 friends. One has $3, one has $2, and one has just $1. Okay, because this negative 35x is like a 1. So how much money can I take from each of your friends? I can only take $1 from each of them. So that's a way to think about factoring out the greatest common factor with variables. So what's left in this one? We have an x squared. Oops. And we have plus 2x. Goodness. I think my trackpad is going to say that it's time for the day to be over. Okay, and we have left a negative 35. Okay. All right here. Okay, so we factored out that x. Now we're dealing with a quadratic again, and that looks like something that we are used to doing. So let's go ahead and do that x. We're always carrying down our greatest common factor. On, I will go ahead and tell you back on number 6, you do have a greatest common factor. Make sure you carry that down. It's going to be in your final answer. So here, this one is kind of an easier one for us, which we like those when we get those. And we don't have a number out in front of our x squared. We don't, well, we do, we have 1, but remember AC method is whenever we have something that does not equal 1. So since we do have the 1, we can factor as we normally would. And we're going to have an x, that way we get our x squared. And let's think about, we have a negative, so we need 1 to be positive, 1 to be negative. And I think that 7 and 5 are popping out at me. Those multiplied to be negative 35, or they can. We have to decide which one's negative and then add to be 2x, a positive 2x. So that means I'm going to need my 7 to be positive, right? So that whenever I add 7 and 5, or in this case, positive 7x and negative 5x for my inside and outside terms, I would get that positive 2x. Okay, so there's our answer, and we're done. I wish you well with your factoring, and just remember what signifies each type of factoring that we're doing. Okay, have a great day.